Hello friends, this is Lakshmi. Good evening to all. Today's session we are going to see about Kruskal algorithms and Prim's algorithm from graph theory. So already we have started, but still we have to complete the Kruskal algorithms. So, so already I have given instructions about this concept. It's very important concept actually, and sure we will get any one of the question Kruskal or Prim's algorithm. Okay, anything they will ask you, sure. So again, I'll tell you, we have set exam and net exam also. This is the right time to start your preparation. So do well, do practice well. Again, so if you have any doubts regarding that while seeing that concept, kindly feel free to ask in comment session also, or just you can join in the WhatsApp group, and you can ask any questions, and we will say post many notes actually, and tables, whatever important things we will share in the group itself. And subscribe on this channel, and continue this one. Thank you. Now we can start. First one, last two questions we saw how to work out the Kruskal algorithm. Today, one more questions. What is the weight of minimum spanning tree using Kruskal algorithm? So already I have told you, Kruskal algorithm, we have some steps we need to follow while doing this question. So first one, we have to check how many vertices are there. Okay, how many vertices? 1, 2, 3, 4, 5, 6 vertices. So vertices equal to, so edges, how many edges I need? Edges equal to formula what? Edges equal to vertices minus 1. So vertices, how many vertices? 6 vertices. So 6 minus 1 equal to 5 edges I have to draw here. That is my first point. Second point, I have to write weight everything is ascending order. We have to go ascending order just from minimum numbers only. So how many 2's are there? 2 2's are there. 2 2. And how many 4's? Every numbers we have to write. 4 2 4. And how many 6? 1 6 double 7 is there? 110. So totally is 4 5 6 7 8. 1 2 3 4 5 6 7 8 numbers. Okay. Now we have to go one by one. First one I'm going to take, this is AC. AC I'm going, this is 2. Okay, this is 1 over. Next one, this number. So this number BF. So BF is there. BF. So this number 2. Okay, this 2 also cancel. So how many edges I have to form? Only 5 edges. Okay. Next to 4. 4 I can connect C to F. Okay, so C to F I can connect. This is 4. This 4 also okay. Next to this 4. This 4 if I'll connect means this 4. This 4 also I can connect, no problem. So it won't form anything circle. So D. So this 4 also I can connect over. Next to 1 what? 6 we can connect. 6 I will connect this one means automatically I'll get circle for this one. So it's not possible. The 6 won't allow actually. So I can skip the 6. No, this one 7 I can go. 7, this one I can go. This 7 if I'll take, automatically I'll get here. This formation I'll get. You can see this formation I'll get. So this is not also, it's not possible. So I can take this 7. Now this 7 I can take. This is E. Now this is over. So 5 edges we have formed. So just you can count it. 2 plus 4, 6, 6 plus 4, 10, 10 plus 2, 12, 12 plus 7, 7, 19. 19 will be the answer. So this is very important question. That's why I have taken previous questions nearly 4 to 5 questions. And Prim's algorithm, apart from that, Prim's algorithms also. Okay, one more questions. Now we can see, maybe they can ask you this type of question also. They can ask you that vertices, what are the vertices first starting vertex and which one is last ending one. These are the things we can, they will ask you. Consider the following graph using Kruskal algorithm, which edge will be selected first. So it's very easy questions. No, it won't take so much of time. So first one, vertex also, how many vertex edges also no need to see here, because we are not going to form every edges. Okay, just the first vertex or first edges only they are asking. So minimum number, in Kruskal minimum number we have to start. What is the minimum number here? 3 will be the minimum number. That's all. This 3 only minimum. So BE. This BE first it will form. That's all. This is the question. Over. Okay, so maybe this type of questions also we will get, because the time management is very important. If you complete the questions, if you know the questions, just you can move on fast for next question. It will take 1 second, but we need many questions. We need lot of time. For example, 5 minutes, 10 minutes also we need some time. So automatically we have to this give some other questions for timings also. Okay, you can see this question. This is also use Kruskal algorithms. Find a minimal spanning tree using this one. Now, this is, see, here we have to work a lot. No way. Now we can see the diagram. First one, how many vertices? 1, 2, 3, 4, 5, 6, 7. 7 vertices. 7 minus 1 equal to, I need to form 6 edges. Okay, this is first over. Now from minimum numbers you can go 2, 2, 2, 2, and 3, 3, this 2 over, this 2 over, this 3, this 3, 3, 2 threes are there, okay? And 1, 4, 2, 4, 3, 4, 4, 4. So 4 fours are there, okay? This 4, 4. Next 5, 2 fives are there, and 1, 6. So here they didn't give anything, so just leave it here. So we have returned full and full. Now we can erase it. This one, it won't be good to work while seeing this one. Okay, now you can take how many numbers are there, just we have written. First you can form minimum numbers. Now AD I can form, AD I can form. Okay, this is 2, 1, 2 over. Next 2, how much this one? This GC I can form. This GC, okay, this GC, this is also 2, okay. This 2 over. Next 3 I can form this AG. This AG I can form this 3. This 3 over. Next 3 I can form this one, no problem. This one also I can form because nothing, it's not connecting. So this 3 over. Okay, this is also over. I have to form 6 edges. Now next to 4. If I'll do this 4, it will make a connection. It will make a cycle. So I can make this 4 I can do. So B to F. F. Okay, this is 4. So first 4 it's not possible. This 4, okay. Next you can make this 4. It's not a problem. A to E. A to E 4, okay. This is also no possible. Over. So 1, 2, 3, 4, 5, 6 it has come. Now you can check it. First one, this is you can check it. AD, yes. AE, next one AE, AG, GC, and GB and BF. This is also correct. Next one, any type, it's not coming any, just we can make anything. Just it's not a order wise, okay. If they will ask order wise, we have to check. See, okay, this is a GC, okay, GC, GB is there, and BF is there, and GA is there, and AD also is there, AE also is there. Next to GC, GC also is there. This diagram you can see, AD also is there, GB, GA, and BF, okay, AE also is there. This is also correct, this is also correct. Next to AD, AD, AG, and GC, and AE, and GB, BF also is there. So I have got every answer correct. My answer will be do 1, 2, 3, 4 also is correct. So in Kruskal algorithm itself, we are getting different types of questions. What is the selection? First select one, which one is the last end one, vertex and edges, and what is the order of this vertex, and sometimes so what same only one concept we are getting different types of questions. Okay, that's very important while doing this one. Okay, next concepts of Prim's algorithm. So what is Prim's algorithm? What is the difference between Kruskal and Prim's algorithm? So here also we are going to see the same thing, minimum spanning tree only. But Prim's algorithm, what Kruskal algorithm, what will do? minimum number of number. First it will take ascending order. First it will take start from minimum number. But prims, it's a arbitrary choices. It will take random anything, anywhere can start. No, it's not a problem. And no need to write ascending order. I'll show you way. I'll show you what is the weight of minimum spanning tree using Prim's algorithm. Starting from vertex A, they have given itself. Okay. Now A have to do. So how many vertex I have to form? 1, 2, 3, 4. No. So this is very important. Vertex minus 1, 3 edges I have to form. So 3 equal to, no, edges equal to. So this is 4 minus 1 is equal to. So 3 edges I have to form. Okay. From A, I am going to take A. A to which one is minimum you can take? So B minimum 10. So I can go B side. Minimum side it will go. That's all. It won't take any ascending order. This is very important. Kindly see to it. Now from B where it will go? 17, 10 already visited, 6. So 6 only it will minimum. So D. So this is 6. From D where it will go? 11, 6. 6 already visited. So 11, C. So totally 3 edges it's come. Now we can calculate 10 plus 11, 21. 21 plus 6, 27 will be the answer. So kindly check it. Kruskal algorithm and difference between Prim's algorithm. It's very important. I told you already. Sure, you will get any one questions from this one, any concept. So you have to know what is the procedure for Kruskal and Prim's algorithm. So Prim's algorithms, we are not going to write any ascending order. First, it will take any vertex. If they have given means we can start from that particular vertex. Otherwise, it's randomly we can take any vertex or minimum number vertex also we can take. It's not a problem. This is arbitrary choice only. Okay, this difference also they can ask sometimes. Okay. After that, the same concept. But no, first starting vertex. From there, it will go with which one is minimum. Like this, it will go. It won't take any ascending order numbers. Now this is you can see Prim's algorithm. Now we can check 1, 2, 3, 4, 5. So 5 minus 1 is equal to 4 edges we need to form. So here vertex 4, starting from vertex 4 they have given. So I have to start 4. Okay. So 4. 4 and only one thing we have to go. So 4 to 3 only. So no nothing for this one. 21 this one. Okay. Anyway, the weight they didn't ask you that, so they asked about the path only. Now, which one is correct? It will go 2 or 5. 2 are going means 11, 5 years going means 22. So which one is minimum? 2 only it will go. So 2 only it will go. This is called 11. Okay. So next one from 2 where it will go? 15, 23, 11. 11 already visited. So it won't take it's 11. Now 15 it will go. So 1 it will take. So this is called 15. So 1 it will take. So this is over. So totally how many? 4 edges. Okay. Next one from 1 where it will take 5 are this one only 2. So 15 already we have taken. So only choice 14. So 5 it will go. This is 14. So 4 edges over. So this is they are asking this vertices. What is the edges connecting? 4 to 3, 3 to 2, 2 to 1, 1 to 5. This is the correct answer. That's all. Okay, this is Prim's algorithm. Okay, so some of the theory questions also from Prim's algorithm. First one, which of the following algorithms is used to find the minimum spanning tree? It's of weighted graph means minimum spanning tree. We have two concepts. One is the Prim's algorithms and Kruskal algorithms. What is register algorithm, Floyd-Warshall algorithm, Bellman-Foods algorithm? That's everything we can. I am going to make one match the following session also, because some questions it will come only match the following this one based concept. Okay, I'll make separately that one. So here it's a minimum spanning tree, two concept, Kruskal and Prim's algorithms. So here they have given Kruskal algorithms only. This is the answer. Okay, so next one, Prim's algorithm starts with what? Arbitrary edge or arbitrary vertex or large weighted vertex or smallest weighted edge. So actually it's a arbitrary vertex. It won't take edge actually. which one is maybe they will give some of the vertex. You can start from this one, so you can start from 4 or any vertex they can give. If they won't give, automatically I can take any types or any arbitrary vertex, we can start and we can move on to the particular concept, which one is minimum, like this. Okay, so Prim's algorithm, this is the concept. And Kruskal algorithm select edges, how it will select ascending order of weight, it will select Kruskal. Okay, and only one questions we can see. Suppose that a connected planar graph 6 vertices. This is a handshaking lemma we can use, each of degree 4. So total 6 vertices, degree 4 they have given. Into how many regions in a plan divided a planar representation of the graph. How many region they are asking. Okay, so region formula, edges minus vertices plus 2. First one, handshaking lemma, sum of degrees equal to 2e. So sum of degree what? 6 into 4 equal to 2e. Already we saw some of the questions like this. And 6 4 into 4, 24. 24 equal to e means e when they adjust, it's a 12. So region, it's to find out region. Next class I'll tell you what is region, what is cyclomatic complexity, and boundary phases. Some of the three terms are equal only. That I'll tell you while taking. So regions equal to E minus vertices plus 2. So what is the edges actually? 12 is the edges. Vertices what? 6 vertices. 6 plus 2. So 12 minus 6, 6 plus 2 equal to 8. So 8 will be the region. This is called answer. Okay. I hope this is clear. This is we are going to see next class. So today we have taken only the Kruskal algorithms and Prim's algorithm, hand-checking lemma one question. So two classes we have completed this one. Really, again, I'll tell you, hand-checking lemma also, it's one of the important questions. Separately, they will ask you. And Kruskal and Prim's, it's very important. They will ask you any one of the question. Okay, do just to do prepare well. Just you can ask me any questions regarding that doubts this session, and every videos you can check it. uh, sure you will get every ideas, whatever subjects, even this one I have started actually. So after that I am going to cover every units like computer arithmetic, computer this one second unit, third unit, everything. Apart from that, side by side I am going to start paper 1 also. Okay. Thank you all of you, and subscribe this channel, and thank you once again.